First, let's understand what data preprocessing is. Data preprocessing is the process of transforming raw data into a format that is more suitable for analysis and learning. If the data contains too much noise and unnecessary elements, it significantly increases the difficulty of learning from the data. This is a crucial step in real-world applications. Just like a gold miner needs to remove dirt and stones mixed with gold sand to extract the gold more easily, data preprocessing involves cleaning raw data to make it easier to complete tasks in data mining and machine learning. In gold mining, mud is an obvious impurity. Similarly, in a dataset, we often encounter clear impurities or problematic elements, such as missing values, noise, inconsistent data, disorganized formats, and various other factors that interfere with identifying patterns and relationships in the data. The ultimate goal of preprocessing is to remove these factors or minimize their impact on learning, making the dataset cleaner and more conducive to effective analysis and learning. Now, let's look at a small dataset. This dataset comes from a restaurant's records and contains 7 data points and 7 features. Typically, datasets are stored in CSV format, though other formats may be used depending on specific tasks and requirements. By default, each row represents a data sample, and each column corresponds to a specific feature. This structure makes it easier to organize and analyze the data systematically. In gold mining, mud is an obvious impurity. Similarly, in a dataset, we often encounter clear impurities or problematic elements, such as missing values, noise, inconsistent data, disorganized formats, and various other factors that interfere with identifying patterns and relationships in the data. The ultimate goal of preprocessing is to remove these factors or minimize their impact on learning, making the dataset cleaner and more conducive to effective analysis and learning. For example, the first row represents the first data sample. The first column shows the table number, followed by the order time, the items ordered, the quantity, the number of guests, the total bill amount, and the payment method. In this dataset, 2 features have a direct relationship: the items ordered and the quantity. Their values should be consistent. For instance, if a customer orders only 1 Coke, but the quantity is recorded as 3, it's clear that one of these entries is incorrect. Such inconsistencies can be very confusing for humans. Similarly, training a model with this kind of inconsistent data can make it much harder for the model to learn patterns effectively. First, take a moment to pause and carefully observe this dataset. Spend a brief amount of time looking for any issues or inconsistencies. If you identify any problems, think about how you might resolve them effectively. I think that 2 missing values should be quite obvious. We have the features bill amount and payment method, and for most data points, we have corresponding entries. This suggests that these 2 missing values are unintentional, making them a clear issue in the current dataset. As we mentioned earlier, this dataset also contains inconsistent data. There are 2 instances of inconsistency that we can identify. The more obvious issue is with 2 data samples where the recorded quantity of items ordered does not match the actual number of items listed. In these cases, we can manually count that the number of items is 4, but the dataset incorrectly records it as 5. Another inconsistency comes from the inconsistent formatting of the time records. As humans, we understand that the format of the time record shouldn't affect features like the number of items ordered or the bill amount. However, when we train a machine with such inconsistent information, the machine might pick up on these differences and attempt to use them to make predictions. Clearly, this is not what we want, as it introduces unnecessary noise into the learning process. Again, we should not use inconsistent data like this to train a model, as it can lead to unreliable learning outcomes. Additionally, this dataset contains a duplicate data point. We can see that 2 data points have identical values for every feature. Notably, certain information that realistically shouldn't repeat, such as the same table at the same time, appears duplicated. This suggests that it's a duplicate entry. In such cases, we should remove one of the duplicates. Otherwise, this data point will influence the learning task twice compared to others, potentially causing the model to become biased. In practice, it's reasonable for some features to have identical values. For example, items ordered or the number of guests might frequently be the same across data points. However, if your raw data contains a sufficient number of features, the probability of two data points being entirely identical and still rational is extremely low. In the current dataset, there is also a less obvious issue, as shown in the figure. In this data point, the customer ordered only one Coke, and the number of items ordered verifies that this information appears correct. However, the number of guests feature for this data point indicates there were 6 guests. It's highly unlikely that 6 guests would order only one Coke, making this entry clearly unreasonable. While such an event could occur in reality under extremely rare circumstances, we should still classify this as an outlier. If we include such outliers in training the model, its generalization ability may suffer, as the model could learn patterns based on highly improbable events and make similar, unreliable predictions. From the examples of bad data we just discussed, I believe you now have a general idea of why data preprocessing is necessary. In practice, we often work with datasets that appear very structured and perfect. However, this is because someone else has already completed the data preprocessing work. Sometimes, we receive raw data that has not been preprocessed. For example, if you design and implement a program to collect data but overlook certain details during its design, the resulting dataset may have issues. In such cases, data preprocessing becomes essential, and this situation is quite common in real-world applications. Therefore, to ensure a high-quality dataset, data preprocessing is a necessary step. Secondly, a high-quality dataset can significantly enhance the performance of machine learning tasks. Well-structured data makes it easier to reveal patterns and relationships within the dataset, enabling the machine to capture these patterns and learn the hidden knowledge more effectively. Similarly, a high-quality dataset can significantly speed up the training process in machine learning tasks. An accurate dataset makes the patterns in the data more apparent, allowing the machine to learn more efficiently. In practice, noise in the data can mislead the machine into learning unnecessary patterns. The machine then requires extra time to balance out the errors caused by this noise, slowing down the training process. A clean dataset minimizes such issues and accelerates learning. Finally, clean and well-structured data helps us better understand patterns and interpret results. You may have heard people say that machine learning often feels like a black box problem. We know the model provides useful answers, but we don't fully understand why or how it arrived at those answers. It's similar to how, as computer science master's students, we can easily answer that 1 + 1 = 2, but we might struggle to explain why or understand exactly what happens in our brains to produce that answer. Although it's challenging, we should strive to improve the interpretability of machine learning tasks as much as possible. High-quality data makes this easier. For example, if we know that most customers are likely to order only 1 or 2 items, and the model predicts a similar outcome, we don't need to spend extra time understanding why the model made that prediction. It aligns naturally with the data patterns.